Carbon dioxide, CO2, in the air is invisible, but we can see many of the things that cause and contain it, such as smog and smoke. CO2 isn't all bad. In fact, we need it, in healthy amounts. Some CO2 emission from natural sources like volcanoes is necessary in order to keep our atmosphere intact around the surface of the Earth. Natural CO2 is different from man-made CO2 on a molecular level that scientists can measure. We know that this healthy amount of CO2 is what keeps the planet warm enough by locking in heat from sun rays into our atmosphere. And without any CO2, all of the heat would escape the atmosphere, rendering Earth too icy and cold to sustain complex life, like other planets in our solar system. But the problem we're facing isn't about natural, healthy amounts of CO2 in our atmosphere. Before the 1700s, the amount of CO2 in the air was never above 200 parts per million. That's because all of the CO2 came from natural sources, like volcanoes. The 1750s marks the beginning of the Industrial Revolution. By the 1800s, mechanical innovations of the Industrial Revolution introduced the first man-made CO2 into our air. And with a steady addition of new carbon-producing technologies, CO2 levels began to increase 100 times faster than at any other time in history. Today, CO2 levels are at almost 400 parts per million. Earlier we explained that natural CO2 is what locks heat into our atmosphere, and that is good. But the additional man-made CO2 now in the air is causing our planet to become dangerously overheated. The additional trapped heat is causing too much of the world's stable and permanent ice formations to melt. And the additional liquid water from melted ice contributes to sea level rise.
Climate scientists believe that this increased liquid water contributes to the larger, more dangerous storms dubbed superstorms, because their increased frequency and severity coincides with the rise in sea level and CO2 emissions. The size and strength of storms has increased exponentially since the introduction of man-made CO2 into the air. Atlantic hurricanes, for example, traditionally had been known to mostly span no further than areas of the Caribbean and the southern United States closest to the Gulf of Mexico. But 5 of the largest hurricanes ever observed as of the 2016 hurricane season occurred over the past 20 years, whose physical dimensions span almost the entire area of the eastern coasts of 2 continents. From smallest to largest, they are as follows. In 1996, Hurricane Lily, with an area of 805 miles, or 1,295 kilometers, tied with Hurricane Olga for 4th largest span ever recorded. 2001, Hurricane Olga with an area of 805 miles, or 1,295 kilometers, tied with Hurricane Lily for 4th largest span ever recorded. In 2016, Hurricane Nicole with an area of 815 miles, or 1,315 kilometers, 3rd largest span ever recorded. 2010, Hurricane Igor with an area of 865 miles, or 1,390 kilometers, 2nd largest area span ever recorded, as of the 2016 hurricane season. And finally in 2012, Hurricane Sandy with an area of 945 miles, or 1,520 kilometers, largest area span ever recorded as of 2016.
Luckily, not all of the largest hurricanes made direct landfall or were also the most powerful, but 3 of them were concerning, considering their sizable dimensions. For instance, Hurricane Nicole in 2016. Although this was a strong Category 4 storm that spanned an 815-mile area, it mostly remained out at sea, making landfall primarily in Bermuda, where it still took 1 life, injured many and caused $15 million worth of damage. Hurricane Igor in 2010, a strong Category 4 hurricane that remained offshore at its strongest. This was the second largest ever recorded, spanning an 865-mile area affecting most of Central America, the east coast of the United States, and Newfoundland in Canada. Although the eye of the storm never made landfall at gale force, Igor cost 4 lives and caused $200 million worth of damage. Hurricane Sandy in 2012 was only a moderately strong Category 3 hurricane, but it was dubbed Superstorm Sandy because of its status as the largest ever recorded, spanning a 945-mile area affecting most of Central America, the entire east coast of the United States, and parts of Canada's east coast. New York and New Jersey were hardest hit. In total, the storm took 233 lives and caused $75 billion worth of damage. More liquid water also threatens low-lying coastal areas all around the globe. This simulation is depicting what part of Hawaii's coast could look like in the year 2100 if sea level rise continues at its current rate. For more, visit itsnotjustpolarbears.org.